Hello everyone, this is the video lecture for Calculus 1, Section 2.1, Tangent and Velocity, or Slope. So this will actually be the first recording for Calculus 1 that we're doing here, and I plan to go through it all. Just as kind of like an understanding of what I'm going to be doing here, I want to talk a little bit about the beginning of each section and how we're going to approach this section, and then I go and do homework problems directly from the homework, and I'll even give you the homework ID number for them. I won't be doing all of the homework problems, just some select few, and I'm wanting to do the ones that stand out or are a little different, or even just the ones that are very typical. I want to kind of get a broad overview of everything that you're going to be seeing as you're going to be doing the homework. So we're going to start here in 2.1, and I'm going to talk about slope. And slope is something we already should be familiar with. So if I write a little m, that's the same as saying slope. We have the formula y2 minus y1 over x2 minus x1. Again, they also call it velocity or tangent. And not necessarily like tangent x or something, though yes, in a way also we'll get to see that again. This is more of like a pre-calculus understanding of it. Yes and no. What I'm saying by tangent in particular in calculus are something kind of like we got a curve here, and say we have a point right here. A tangent line moves like this. It's just touching at one point, and that's a tangent line. What we're going to be wanting to find out for that is, what is its slope? And so we would be using, what's another way to do slope is rise over run, and all kind of things. I guess you could say like y over x. There's so many other versions, but again, we're just trying to find the slope and use the slope on these particular problems. So let's get started on some homework problems. I got 21001. So again, this is the ID number for that homework problem. It's in 2.1, my section 2.1, and then we got question 001. Now, this is not necessarily number one on your homework. Now, in this particular case, it probably is. I really can't remember. I haven't looked at the homework in a while. I'm just kind of looking at my notes here. I'm not going off of like, oh, this is number one on your homework. This is number 5 on your homework. No. I'm saying this particular ID is on your homework. Now, what you can do is use this to find it in the book. So you can go to the ebook, and you can go to this chapter section, and then question number 001, or just 1 in the book, will have something very similar to what we're going to do here. So I'm correlating it with the book and with the homework, with like the WebAssign kind of system, not necessarily number one on your homework, okay? Though I do often do number one on your homework often because it's kind of a nice like introductory kind of question. Anyways, so here we go. I got T, and then I've got heartbeats. And sorry for the terrible handwriting. You're going to have to put up with it for the rest of the semester. That's just part of it. Sorry. So I got 36, 38, 40, 42, 44. These are times. And then they give me some really big numbers. 5203. I'm sorry, 2503. Dyslexia, it happens to everybody. So 2645, 2785, 2919, and then I got 3050. All right. So what they're wanting here is they say find the slope of the secant lines. I think it's plural. So secant line. We'll just start with singular here. What is a secant line? Is that meaning like secant of x back there in pre-cal land? No, definitely not. What a secant line is, we already talked about tangent lines. Secant lines are when you have 2 points and you connect them with a line. And isn't that interesting? You're looking for the slope of this line, and because it's a secant line, it requires 2 points. And I don't know about you, but I think it's kind of a requirement to find the slope using 2 points. Like, how do you find a slope? You take 2 points, and oh my gosh, I have a formula for that. I got my second point, I got my first point, put them together, and there you go. So in a way, this is like the typical way of finding slope, but they're going to be trying to use this in a way, in an understanding where we're going to get to a tangent line. But for right now, secant lines are just 2 points, and so here we go. We have part A says use t equals 36 and t equals 42. So we're wanting to use this one and this one. And what we're going to do is say this is my x, y1, and then I got my x2, y2. And then I just put them together in my formula. So my slope should be then I've got 2919 minus 2503, all divided by 42 minus 36. And I'm just going to tell you I got the answer from the calculator, 69.333. There you go. Cool. Done. Part B says, hey, let's redo it again for 38 and 42. So now we're going to be doing the 38 and the 42, basically the same thing. And so my slope in this particular case is going to be the 2919 minus the 2645. All divided by, again, that 42 minus the 38. Calculator, 68.5 is my answer. And I did not continue to do anything else. I just said, etc., continue moving on. And there you go. So I'm not even going to finish the problem from the homework, but you could see the pattern and the formula that we're going to be using to get that answer. So there you go. Next question, 003. So I've got a point at 3, negative 3. And then they give me this function, y is equal to 3 over 2 minus x. Okay. There we go. So I have a function, and I have a point, and what they're wanting is saying find the slope, part A, find the slope at x is equal to 2.9. So the thing is that we have this point here, and this 3 is really close to 2.9. In a way, we're still doing a secant line. We're still doing 2 points to make this thing up. But those 2 points are so close together that what it eventually is going to be, hopefully, is going to turn into a tangent line where there's only a single point touching. So that's the goal here, is that they're going to take the secant line concept, take these 2 points and get them really, really close together, and it should approximate what a tangent line would be at that point, 3 in particular. And so that's the goal here. Let me show you how this works. It's very simple. What we need for our formula is y2 minus y1 over x2 minus x1, correct? Well, we have, let's call this one here my x1, just because it's kind of like sequential. This is 2.9 and then a 3, like number line-wise, 2.9 and then a 3. So this will be the first and that's the second. Doesn't really matter in the end. Actually, no, I'm calling this the second because I'm going to put it there. Yeah, sorry. I'm going to call it second. It really doesn't matter. If you know anything about the slope, you can do it either one way. I'm going to just call it 2 because apparently that's what I did on my notes. Whatever. So this will be my x1. Always watch to the end. I might make a mistake. You never know. And this is actually my y1, but where then is my y2? It's actually right here. But what I need to do is plug in that x value of 2.9 in order to find out what that's going to be. So blah, blah, blah. We have some numbers. We got another number, and then we got a function. So my y2 minus y1 actually ends up being a 3 divided by 2 minus 2.9, just the 2.9, sorry. Kind of skipping ahead there. Minus a negative 3. And then I've got my x value here is going to be the 2.9, and then minus the regular old 3. So I basically just said my x1, y1, boom, boom. And then I got my x2 and my y2. Again, you have to plug it in. And then you would get your answer. So I know it looks kind of chunky, blah, 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 calculator, and we get 3.3333333. I think they want like 6 decimals into this particular case. So, yeah, there you go. I mean, they say 6 decimals. There you go. That was all part A. Part B now says repeat with a 2.999. So you could see the pattern here. We're not really changing much. We're just going to do the 2.999 component. -3 doesn't change. 2.999 minus the 3. Calculator for sure. And I got 3.003003. They say 6 decimals, so I'm going to go 6 decimals. I'm hoping that you're seeing is that we're approaching 3 as my answer. We started with 3.3. This guy was probably 3.13, and then we got 3.003, and then where are we eventually going? 3. All right, so that's going to be the slope of the tangent line whenever we get there. Oh, apparently we're continued. Yeah, so I flipped the page on my notes, and yep, this is actually part C, is what is the slope of the tangent line? It's 3. I just told you. Okay, great. So we just did that. But now they want part D, I guess. I don't know if it's really part D or whatever. But part D, they're wanting the tangent line equation. Okay, now this is where it gets a little different. My tangent line, there's a line equation, y minus y1 is equal to m times x minus x1. Do you remember that one? So we have an m, okay? We have an x1 and a y1 right there. Now I'm kind of happy that I labeled it x1, y1 there. So 3, -3, and so that would be right here. This would be a 3, a -3, and a plain old 3. I know there's a lot of 3's, but I should just be able to plug them all in and get an answer here. So 3x minus the 3, and yeah, we're done. There you go. I don't quite know if it'll accept this in WebAssign or not. I think it will, but I just want to tell you here, again, if you don't know much about WebAssign, WebAssign is really flexible with its inputted answers. It understands that things change and can be rearranged and everything. So what I often do, me personally, I don't simplify very much for myself, but I do simplify sometimes in a note so that you could see where I'm going and some particular concepts there. So like if I just left it like this, yay, great, awesome, does it work? Sure, but what is the point? And I want to go a little bit further. So I want to show you me simplifying this just a tiny bit so that you can kind of see a bigger picture here. First off, distribute. 2 negatives make a positive, of course, minus the 3 on both sides. And so we get y is equal to 3x minus the 12. And that is your simplified answer. This is like what I would actually type in to WebAssign. That's what I have on my notes. So I simplified it down so that you can see that it ends up being an mx plus b format. This is just a line. And so I'm not going to draw that line. I'm not going to go through exactly what all this looks like. The big point, though, is that we're getting it down to something very familiar. We had a formula that we remember. We plug stuff in. We have something that we've seen before. Shouldn't be an issue. All right. Let's keep going. 21006. Again, not number 6 on your homework. I don't know what number this is. It might be number 3. It might be whatever. I don't know. But it's just, this is 006 identification number. It says that we have a velocity of a rock. A rock is 14 meters per second. There we go. And it's dropped from a height, or it has a height function of, yeah, it's a height function. Y is equal to 14t, trying to make that look a little bit better, minus 1.86t squared. Okay. Before I keep going, I want to talk about what's going on here. This is actually a position function, and the rock is being thrown up in the air, and then it comes back down and all that kind of stuff. How do I know? Well, this right here is that initial velocity. That's a positive, as meaning going up, so that's velocity. It's not a coincidence. Velocity. velocity. There you go. Sorry, bad spelling. So what's this guy here? He's actually gravity, and notice that it's a negative, and that t squared kind of gives it away because it's making this parabolic. Comes up, maximizes, comes back down, hits the ground, kind of stuff. It also starts from the ground because basically this is a plus 0. There's not a constant in here to show how high it started, so it must be 0. All right, cool. So what are we going to do with all this? Well, part A says that we have 1 to 2. Find the average velocity. The average velocity in this interval. So the intervals from 1 second to 2 seconds was the average velocity. What they're really wanting here, guess what? It's the slope. So yeah, woohoo! It's nothing new here. Again, we've all done this before. We're going to do it again. Same formula. My y's are going to come from this, and my x's are given. These are my x's right here. And that's it. So yeah, here we go. I have, for my first one, 14 times the 2 minus the 1.86 times the 2 squared, all minus, and then again, doing the same thing, 14 times the 1 minus the 1.86 times the 1 squared, and then all of this divided by 2 minus 1. Again, I'm trying to choose the bigger one and then the smaller one here. That's what I wanted to do in the last one. Blah, 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 calculator, 8.42 is my answer. And then for part B, we're going to repeat it. And they say go from 1 to 1.01. You can notice, those are both square braces. You can notice that we're trying to hone in on this. We're trying to use the secant line concept, and we're trying to bring it down into a tangent line. I'm not going to go through all the particulars. It looks just like this and what we just did a second ago. You're just changing these numbers right here to, guess what, a 1.01, blah, blah, blah. And my answer is, so you could double check yourself, is 10.2614. That's what I got. And as you keep going, this is, you know, we got part C, you got part D, you got a part E. If you keep going, your answer is 10.28 at the very last one. And then part F, or whatever the one is after that, it says, what's the instantaneous velocity? And what they're wanting to know is basically this tangent line thing. Well, you're going to use the last answer. And so you'll be using the 10.28 again. So there's 2 boxes at the very bottom, basically, that you'll be, and this is for t equals 1, by the way. You'll just take whatever answer you had from the last whatever you were doing, and you put it here, again, just duplicate it, and, well, that's your answer. So it's actually pretty easy. I think that it's kind of a confusing question, like, what am I supposed to do? How do I actually find it? You already found it, basically. just give it to them. It's okay. 2.1009. And I think this is the last question of this section, so that's cool. We got a point, 1, 0. We have a function sine of 17 pi over x, something kind of like that. They want you to go to 4 decimals, okay? And they want the secant slope, secant line slope. Secant line slope stuff. Okay, so again, basically 2 different points. This is my point 1, so then you'll say x1, y1, and then for part A, they say x is equal to 2. What they're wanting here is x2 and y2, then you would plug that thing in, so sine 17 pi over the 2. I'm just going to go ahead and tell you, if you ever see anything kind of like this, make sure you're in radian mode. Make sure you're in radian mode in your calculator. And by calculator, I don't necessarily mean TIs and Casios. What I also mean is Desmos. And so you could use Desmos Scientific, and I would recommend doing that. So Desmos Scientific or whatever else, you can use a hand calculator, just as long as it has a radian mode, because that's going to be important here. Make sure you're in radian mode. It has to tell you something blah, blah, blah degrees to actually be in degrees. Okay? So this is my y2 and an x1, I'm sorry, y2 and x2. There you go. And so I'm just plugging them back into this formula here, nothing new. So sine of the 17 pi over 2 minus 0 right there, divided by my 2 minus the 1, again 2 and a 1. You plug it all in and you get 1.0000 because this is 4 decimal places. So there you go. Cool. And then it says for part B, repeat for x is equal to 1.1. And so again, all you're doing is changing these two numbers right here. You change that to a 1.1, a 1.1, blah, 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 blah. I got negative 9.8982. And et cetera, et cetera. If you go and see all the part A, B, C, Ds and all that kind of stuff, I'm going to say that at the very bottom, they're going to ask you something, and your answer for this one's going to be not approaching any particular value. Something like that. It's multiple choice. When you keep on doing this here, you got positive 1.0, you got negative 9.8, something like, they said use something kind of like 1.00001. I don't know if this is me or them or something like that, but you're doing something like this and you repeat the whole process, and my slope ends up being a 53.41. And I mean, you could see it's all over the place. We got a positive 1, a negative 9, a positive 53. Nothing makes sense. I have it boxed in because this might actually be like an answer to part F or something. I don't know. Again, I haven't really looked at the homework proper recently, and that's okay. I think that's for the betterment. I'm just wanting to do the math here with you. But my notes say to do this, and I think that's a good thing to do. So there you go. And that's it. That's all I got for this section. So I basically stop at these sections here, and then I move on to the next section with another video. And so that way we can continue on and have more calculus fun. So that's it. Thank you very much, and have a great day.